All right.
I'm okay.
All right, Charlie. No problem.
You know my room?
All right.
You know my room, bro? Y'all might get so too.
All right, everyone. We have 1, 2, 3. I guess we can start. Let me find out from Nick if he's going to join us. Where's this guy? All right. So if you are around and you can come to the workshop, that will be no problem. You can do that. Else, you can also stay here. So while we're about to start today, and what we are going to do, it's going to be quite simple-ish. I guess. I mean, it's going to be simple. Don't mind me. Don't mind me at all. It's quite simple what we're about to do today. It's just building on a few concepts that we've done earlier, and then we will just blow it out of proportion. Okay, not blow it out of proportion, but we'll take it another step, right? So okay, I don't see Kobe on the call anymore. It's Francis and Louisa. Okay. All right. Okay. So Nick won't be joining us. All right. So we're going to go ahead and do this. Today is September. September is 9, right? Okay. Attendees. So if there's anyone else on the call, let me know. But for now, it's Barnabas, Mo, Francis, O'Hara. Is there an apostrophe, O'Hara? Capital. Okay. Sorry, forgive me, sir. Louisa. Kwabena Boateng. Honorable Kwabena Boateng. Alright. Is there anyone else on the call? Alright. So I guess up till this point, everyone knows how to send hello world over TTN. I don't know if you do not, maybe let me know right now and we can do that. We can do a quick catch up, I guess.
Let's do a quick catch up.
Okay, alright, no problem. So but you know how to add a board, right? You know how to add install board? Okay, so you did that.
Yeah.
Alright, so let me do this. Alright, so this is what we have here, and ideally, you also know how to. Let me just go ahead and do this quickly.
Yeah.
Alright, so you know how to create an app, really, right? So what you do now is, you come here to the app you created. The app you created, you go to end devices, and then you give it a device ID, an app EUI, device EUI, and an app key. So remember, if it's an EUI, you just use for this one, because it's little endian, it means least significant bits first, right? So you click this to put it in this mode. You can select LSB or MSB, right? So if it's EUI, you for this library we are using the AccraWAN LMake library. You can use this. You can it's little endian, so you put it in this format. But for the app key, it's really more like a memory location, right? So you do not edit the memory location. You do not make it little endian. It can be in big endian format. That's the only difference. And so you declare them up here. So your app you define them here, so you can just use them over here. And for the hello world, all you're sending is hello world, right? So no biggie. And
with the app EUI and the EUI, isn't it changing the way it's displayed?
yeah, it's changing the way it's displayed. No, so watch this. So you have 9876 B6. This is the raw format, right? If you look here at my app EUI, right? See, the last digit here is FB, but over here FB starts, right? Then 41, then 52. So it's reversed. When we say little endian, the bits are like reversed, right? So this is what the bytes are like reversed, right? So this is what it is. So based on this library, it takes the format in little endian, right? So that's why it looks this way. The idea, it could look another way. Okay.
Okay.
Then with the app key, right, endianness doesn't apply. If you look at the comments here, right, for example, it says here this key should be in big endian format, or since it's not really a number but a block of memory, endianness does not really apply, right? Because if you want to go to memory block 001 and then you are going to memory block 110, that's totally different, right? So that's why you're doing that. Okay, so there are a few things you might want to look at. So usually over here you can define the payload you want to send. In the example we'll do, I'll show you. And then you declare a send job, right? I'll show you what that is, an OS job. Like I will show you why you need that soon. And then you have the TX interval. So TX interval is really how many when it sends one packet, how long should we wait before it sends the other packet, right? So it could be 1 second, it could be 5 seconds, it could be whatever, right? In certain scenarios, somebody is calling me, I don't know who, let me just confirm. Hello? Yeah. Hello? Yeah. Yeah, Francis, but we are having a AccraWAN meeting, so. Sorry.
Francis.
Yes.
Francis. Hello.
Yeah, Louisa.
Hello.
Are you with Barnabas? Just yes, you.
Yeah.
Just wanted to confirm. Thank you.
All right. Yeah, if you want to come around, you can
Is
come.
someone else there? Like I didn't take
It's
it
just
there.
me and Francis. Hello?
Who says? Ish.
Yeah, it's just me and Francis here, so you can come if you want.
Ah. Here, come.
Alright, no problem.
Okay.
So TX interval is really the distance or the length of time between transmissions, right? And yeah, and then over here for the feather, based on how the LoRaWAN module was, the RFM device was connected, right? This is it here. So this is a SAMD feather, right? So you can use this pin mapping. If it's not and it's another type of feather, all he was really doing is like setting up different types of feathers, right? For different types of boards, right? And then if it's like the Arduino Catena, like MCCI Catena 4551, so everyone has their own, every board has the way that they connected it, and so he just made that there. And you don't really need to touch the stuff yet unless you really know what you're doing, but it's just a bunch of events that he's saying. So whenever there's like an event, it will print the time at which the event occurred, and then it's going to scan time out, like it's going to check the type of events and it will write it down. So there's stuff we call enumerations, right? And an enumeration is more like a known value that you set. So EV scan time, it's like an enumeration. EV beacon found is like an enumeration. EV beacon missed. So depending on the type of event, right? If it's joining, it says joining. If it joins, it will write out the device address, the network key, the what's it called? Okay, I don't know what arts key is right now off the top of my head. It'll write out the session, like it'll get the sessions, then I'll write out the net ID, device address, the app session key, and it writes all those out. Like it's just for you to see, right? Then set link check mode 0. So you turn this off, right? So look at this. So this is a good document for starting because it tells you what the things do, like disable link check validation. It's automatically enabled during join, but because slow data rates change max transmission size, we don't want to use it in this example, right? So, and then he talks about this event that is defined by not using the code. So it doesn't matter, like you don't need to waste code space on it, for example. Then if it fails, so there are a bunch of events that you just check out, right? And I'm not going to like go over all of this. You can look at them at your own convenience. Now, so this is where all the work happens, right? In this do send, okay? But before we look at that, I'll come back here. And so let's say you have a device you want to work with. Yeah. So let's say you have some boards that you want to work with, right? Let's say your temperature sensor, whatever. You can come here and put everything, like the device initialization in the void setup, and then you call OS init, I'll make reset, set link check mode. You said the DRTX power. You can read about that as well. And then you said you put the sub band one, like you comment it out or you delete it. And the reason why you want to do this is because like you're using 868 megahertz, not the EU 915. So yeah, then you do the send, right? And you send it, like you call do send, and the send job, you pass it in there, right? And in the void loop, you just call OS run loop once, okay? And the reason why you have to call this is so that some registers and things in memory can be handled, right? Else, you won't see that. And then over here in the do send is where really all your data happens. So you send your transmission data, all those things happen here, right? And so when you upload this code, all you get is like you would see the hello world example, and you won't really see hello world. It's some jumbled bytes. We all looked at that, right? And some things you can come to tools. Make sure if you're using the feather from Adafruit themselves, you know, the board will be MCCI Catena 4410, LoRaWAN region, Europe 868 megahertz, LoRaWAN network, generic, subband, default, works everywhere, right? And then you're good to go. Now, yeah. Now watch this. So over here it says if lmake.up mode, like it's in operational mode, and this is still not, like, you know, it's still pending, then, you know, it's going to say not sending, right? Else this is what happens. And lmake.set tx data to, this is really where the data gets transmitted, right? And it'll say packet queued, and when the packet like has been sent, you know, the sent event happens, right? Because it's over the air activation, it happens when you are sending data, right? Then it will say, you see, EV events, in the event that the transfer is complete, right? Then they have received ACK, so you can send acknowledgements back and forth, but for certain types of things you might not want to do that because it takes a while, right, and resources to do acknowledgement. So you can, for something like, let's say, sensor data that you're sending, you can just keep transmitting, because if it's going through, right? You can just check on the console to see if it's going through, you know, rather than trying to do acknowledgements and draining your battery. So that's one thing. So I guess that's really what this one is. Since we've all kind of are supposed to have done this already, I won't waste too much time on it. I will go here and show you what I did, or what we yeah. So yeah, this is another example that I worked on. The code is on GitHub. I'll share it with you guys when we're done. But for now, I mean, I'm using the SHT35. It can do a whole lot more than I did with it. It's just to kind of put the concepts of what we're trying to do over here. So if I open my serial monitor, alright, so I will show you this. Then we can check this out. Okay. All right. So let's see. We have this over here, right? And a bunch of these will seem familiar, except the SHT library that I added. This is the libraries I added are all here. So if you need to download them, you can use them and download them, right? And most of the stuff that you see, you've already seen in the previous example, right? The app EUI, device EUI, app key, you know, sea level pressure. This is just the value we are defining here, and then the address for this. Then, you know, you create an instance of the module you are using, right? And the next thing is, yeah, so we have this print hex 2. Then we have this on event. Let's not look at those sides because you've already seen that. I'm more interested in. All right, so we have our OS job here. Okay, as always, and a few things that are different. Let me just show you so that it makes sense. I don't want to rush. So yeah, we declared OS job, but here we have like our payload, which is, you know, an array of size, but I guess it's 5 items, but we are using only 4. And then we have our transmission interval. This time it's 30 seconds, right? That's the only difference, you know. So let's go look at the voice setup. Okay, and so this is our voice setup. So while serial, like before it starts, I just delayed like 5,000, like 5 seconds, just so I can see it here. You know, don't mind me. And then, you know, I write starting, and then the file. I don't think I'll put this in like an actual thing when it's running, but for now, this is what it's saying. Yeah, even though it's already on the board, right? But wherever the file came from, we could write it out. It doesn't really matter too much. Then we have our SHT library version. It's inbuilt, you can call it, you can decide not to call it, doesn't really matter. Then we do wire.begin, and this part is really what you need to do to work with, like with this library, how to work with the this one. Look at this here, the demo, right? It's an I2C device. So this is really the code. I just added that I just put the exact thing in the void setup here. The only difference is the board rate, right? So that's one thing that I did. Then we have the usual OS in it: LMake resets, set link check mode to 0, this side, and then the subband commented out. You can delete it if you want. I just commented it out so that it'll show you that whenever I see it and you're using 868 megahertz, just kick it out. Then let's do, like, we have our do send over here, right? Then we have our void loop that says OS run loop once. Okay, so this is still basic stuff, right? Like, you can see that everything here you're familiar with. If you know how to initialize a device, you do it in your setup. And then ideally, like usually when you're building your service, you put this whole side in your void loop, but right now you do it in do send, right? And so over here, right, you read your temperature, you read the humidity. Okay, so everything else I'm about to show you, I want you to understand this quite well. So we have to encode the data before we transmit it, and the reason why we want to encode the data, first of all, yeah, you can say security, not really security, because it's fairly easy to reverse the stuff, right? Unless I guess if you build your own encoding module, nobody would know how you did it, so you can decode the data yourself. That's up to you. Or another thing you could do though is that with this you could this whole side is I guess security could be another reason. Another reason is that you don't want to waste too much memory, because if you can shrink all the data into smaller pieces that you can transmit, that would be great, right? So for numbers like temperature, humidity, we see over here that like you have a 16-bit there. You have 16-bit data, right, or 2 bytes. So there's quite a huge integer space, or a huge number space or value space that you can use, right? And what you're doing now is that, first of all, to work with this algorithm, you divide this by 100, right? Makes the number even smaller. So it's like usually pure decimals. And then, so let's work with temperature for now. So we have temperature here. Where's my VS Code? Let me do it from VS Code. So let's see. Alright, so we have temperature here. Okay, now we divide it by 100, so the value changes, and then we set payload, like we just use some variable, and we call this, right? And so if you look at the LMake, the MCCI library, right, for this, you'd see this here, and this is really well documented. It describes how all the encoding was done, right? So it says converts a floating point number to SFLT 16, encoded, and he explains this here, right? An unsigned floating point number in the range 0 to 1, transmitted as a 16-bit field. The encoded field is interpreted as follows. So you can read more about this, how he did it. I guess if you understand this, it'll be easier for you to decode the data, really, because even though there's a decoder here, there's a little thing you have to do just before you decode the data, right? And so yeah, we have this here. And so first you do the encoding, and now the data changes. And then since a base 16 number, right, in assembly you'd see something like this. Let's say you see something like, let's say 8543, right? So what it does is that, let me show you. This is the high byte, okay, and this is the low byte, right? Like if you take any number, okay, so it's like maybe probably so we had this number, and now it's going to be broken down into 0x85 and then 0x43, right? So this is what happens. It gets broken down, and we work with that. So that's the first part, or the most significant byte, right? Or the high byte really goes into the way I did this example, right? Instead of creating the array, so let's say doing the array 0x85 and then 0x43, right? This would be like, I guess, MSB. What I did in this example was that I did the LSB approach, where I did a little Indian approach. So 0x43 and then 0x85. I mean, it's up to you, you know, but I just also wanted to kind of take this a little extreme, you know, but don't mind me. Don't mind me at all, right? So I do that, and then payload 0, payload 1 gets filled with the temperature value. Then you come here to, and with the humidity, you know, index 2 becomes the low byte of the encoded humidity, and then index 3 becomes the high byte of the encoded humidity. And so, I mean, you can write this out, you know, this whole part is just, you don't necessarily need it. Ideally, in a real system, I won't even write all this to serial, but it's just because I'm teaching and I want you guys to kind of see what we're doing, you know. It just made sense that I do that. So feel free to remove some parts when you don't need them, really. So I'm going to go here, and I'll bring up the serial monitor again. And what do I do? Tell me what would I do? All right, so we have this, and it's called an EV joining, right? It takes a while. EVTX start. And so right now we know that this is the humidity and the temperature in the room where I'm at, which is pretty accurate because, you know, I have the AC running. Okay. Yeah. So let's do this. Now that we have this over here, right? Oh, says no join accept. That's interesting. Did anything happen to the cable? Are the gateways online? Why is this happening? Anyways, I will check it out right now. Yeah, it says accept join request. But it says no join accept. Well, let's see. So we have gateways. We have both gateways here, and they're like literally right beside me. And okay, let's see. Maybe this time it will accept the join request. Nope. Nope. Okay, don't worry. Let me disconnect it from my. Let me put it back here. Okay, should work this time. Alright, so it's gone through, and now it's sending, because we don't have an antenna on it, you know, sometimes it likes to flex on us. So yeah, but don't feel bad if you don't have a gateway of your own. If you build a device and it's in range with a gateway, it will transmit whether or not you do not have one, right? So don't really feel bad if you don't have a gateway. So this is the featherboard test that we did, and so yeah, now we have this, and since we are doing over the air activation, it would activate when data comes, right? So first of all, you know what, let me go ahead and delete this. Alright, so when you go to payload formatters, right, there's in the repository there's also a file for this, right? But I'm just going to explain to you. Let me show you how the data comes first, then I'll explain this to you. I hope I have all the logs from way earlier. Alright, 320. Yeah, first of back then I was trying to decode the data, but I wasn't doing it well, so ignore this temperature for now. Usually when the data comes, it doesn't even contain this decoded payload bit, right? It's just FRM payload. Okay, so I came here, right, and then in the default decoded example, you know, when it says return bytes, it just says input.bytes, right? Now, in order to so remember when we were about to transmit the data, we did something. After encoding, we split it into the high byte, and then the low byte, right? So now we have to recombine them so that it looks like so that 0x85 becomes 0x85, 0x43 becomes 1, right? So it just becomes this instead of this broken down chunk. It's actually instead of this broken down chunk, right? So to do that, well, I mean, you might need to know a little bit about, you know, like if you did logic gates or assembly or something, right? So to do that, you know, I did a logical AND of. First, I got the high bytes and then the low bytes, right? Because if you look here, I intentionally put the raw format of the payload here, right? As I was saying, ignore the 0. I just put it there. I could take it out, but yeah. So we have this, right? 5.116.199.125. Let's assume this is the data, right? So we know that this side here is the high byte and this is the low byte for the temperature. This is the low byte for humidity and this is the high byte for humidity, right? So in order to put them back together, you know, first I say high T for temperature and I get it. I just point it to the location where it's at. Same for the low. And what I do is that first I do a logical AND with 0xFF. That's the biggest value in base 8, right? So 0xFF, that's 255, right? Yeah, that's 255. Just to prove that I'm not hungry. Yeah, that's 255, right? So that's 0xFF. Now that we have that, okay, where is it? Yeah. Let me open this in here. You call that a JS, right? So that's 255 over here, right? So we do a logical AND with the high temperature bytes, right? Then we shift it we shift it to the left, right, 8 times. So we do that, and then we do a logical OR, because the reason why we're shifting it to the left 8 times is that right now it's like a base 8 number. So when we shift it to the left, then we are going to what's it called? So if you do a logical AND with a number, it's just going to be the number itself, right? So like logical AND of FF with a number is going to be the number itself. So we do that, we shift. So let me just show you. So let's say we have this, right? So we have 0 so 85, right? So hold on. All right, so 8 in decimal, sorry, so okay, so when we do 8, 5, right, that's going to be, oh yeah, 8 is this 1 0 0 0, 5 is 1 0 1, right? Okay, so we're trying to put them together again. So let's say assume high t is equal to 0x 85, low t is equal to 0x 43, right? So with IT, this is it, and then let's say low t, right? And for low t we have 0 1 0 0. I guess that's what 4 is, and then we have 0 0 1 1, right? That's 4 3. So what we are trying to do is put this and this together side by side. So logically, when you think about it, for this to become 16 bits, we have to add, right? So we have to add 8 more zeros. You get me? And then for this to stay in the low, you get me? And then when you add them, they will become the same, right? So in order to do that, first of all, you do an AND with this one, right? So if we say so this is what we are trying to achieve, right? And so if we want this, what we do first is that we do high t and 0x ff, right? So what does that mean? That's 1 0 0 0 0 0 1 0 1, right? And you do AND 1 1 1 1 1 1 1 1. So you know the truth table for AND gates, right? I don't know if you did that in maybe SHS or right, but AND gates, basically it says if you don't do an AND of a 1 and another 1, it's going to be 0, right? So if you do 0 and 0, it's going to be 0 because it's literally multiplication at the bit level. So let's look at this. 1 times 1, what's it? It's 1, right? Then 1 times 0 is 0, 1 times 0 is 0, 1 times 0 is 0, right? Then you do the same. 1 times 0 0, 1 times 1 1, 1 times 0 0, 1 times 1 1. So you realize that the number is in this format. So you ask, why do we need to do this? I don't know. I guess it's standard I follow, but I also kind of, so if I was doing something and it was like in a memory block, right, like let's say in assembly, I probably would do this. In this way, I don't know, you could overlook it because, you know, it doesn't change the number by any specific way, right? So I don't know why I did that, forgive me. But yeah, so after we achieve this, right, so I guess to also make sure that the number is in its really true form, then the next thing we did was shift to the left by 8 times, right? So when we shift it to the left by 8 times, now it changes from this to become 0x8500, right? Which is very different from just 0x85, right? So after doing this, right, we come here to, and we can say low t and 0xff, right, which is just going to be itself. Okay, so the way we did that, you know, hey, 0 0 0 0, yeah. So I guess I could have done 0 0 fx, right? So that, but it's really like 0 0 ff, right? And for that one, it's really going to clean it up. But what I did was, and right, by then, yeah, I don't mind me. Sorry. So this is going to be sorry, this is 0 1 0 0 0 0 1 1, right? And then we go all over again, 1 1 1 1 space 1 1 1 1, right? That's what we do. And what do we get? It's still the same number, right? Inside low t, which is this thing. Okay, then what we are doing now is that we are doing a logical OR. Okay, and so what we are saying is, so let's do this. Right, so we're doing addition, really. So when you do a logical OR, you are adding its bits, and it's really on the bit level, yeah, it's addition, right? So when we do this, we can say enc temp equals, you know, the new states. So let's say hi t new, right? Just so we know that this is the new states that it became, right? And we are doing hi t new plus a logical OR, because I don't know how, let's say OR, right? This is the symbol for OR. If you're doing like Xilinx or some type of what's it called, HD or hardware description language, you might see different symbols, but for the most part, you know, you get away with this. So low t new. I hope I'm going at a good pace. Like if I'm not, please feel free to stop me. How many people are on the call? Okay, Isabella is here. Okay, I'll add her to the PowerPoints. Right, so what we say high t new or low t new, right? What's going to happen here? So let's do the right. So let's say enc CMP, right? So let's do this together. 1 or 0, what's going to be the answer? 1, right? Good. Then 0 or 0? Hello?
0.
Yeah. Then another 0 or 0, 0, 0. Next one, let's go quicker this time. So 0 or 0, 0, 1 or 0.
1.
Yeah. Then 0, 1. So I mean you get it. Then we go 0, 1, 0, 0. 0, 0, 1, 1, right? And so right now we have a new value which is 0x8543. Okay, so I have taken my time to really explain this part. If you don't understand, just shoot me a message. But all this stuff I'm doing in the code is going to stay there, right? Just so that you understand why I did this. Okay, so now you put this value together. Okay, then after putting this value together, see, if you come here, right, the MCCI link, you know, it shows you like how to decode the value, right? Okay, but it doesn't put the values together for you, so you have to do that yourself, right? You have your raw SFL T16, okay? And so if you have that, then guess what? You can just call this. You can just call this function now. So you can see that I copied and pasted this function at the bottom here, even with all the comments, you know, because this is an instructional. If you're putting it in TTN, you can decide to remove all the comments, and you know, because you're building it, you know where to get this thing from again, right? But comments are good. I mean, it doesn't cost you much to put comments in there. And then we have our high, so we do the same for humidity, right? So now I guess you understand why this line is very important. So that instead of putting like values separated by commas, you just put the number back in where it's at. So you see over here I call temperature, right? Now when we call this, right, we are not done. Remember, before we even did the encoding, right, if you remember from the code, before we even did the encoding, we divided the number by 100. So if you're done, you're going to get a decimal, and so you multiply by 100 so that you put it back in the form where it was before it got encoded, right? And I guess that's a way of kind of keeping some bits preserved and stuff. So this is it really, and you can see that we are returning this data object, right? So now if we look in the things network, I am going to open. So that's what we pasted here, right? You go to this side, and then you put it in here, like in your default uplink payload formatter. And so for every app you are building, you can decide to do it on an end devices level, which doesn't really make sense to me. Like for the most times, like you can have instances where specific end devices you want to do different encoding, which is fine. Okay, it depends on how you want to build your system, but generally if you're doing as little work as possible, it's great. I mean, don't mind me, I'm not an expert at this like philosophy of coding, so don't even listen to me at all, right? So now after you decode the data, okay, I'm going to bring the serial monitor side by side, and you will see a few things, you know. So over here we have 24.82. I guess it's getting much colder. The AC is set to 23 degrees, but it's still running. That means, you know, the room isn't at 23 degrees yet. So I guess we can take the data coming in as credible. And let's see. So this is the last data that came, right? And over here it says 24.82 degrees Celsius. And over here too it says the same thing, 24.82 degrees Celsius, right? So you might want to either truncate it's up to you if you want to truncate the value after this, or you know, I guess JavaScript always adds its own decimal places after, you know, I think it's 12 decimal places or something. Okay, JavaScript, thank you very much, you know. But like, yeah, it's great for a lot of things. And so if I hover on this, it's 24.87, and over here it says 24.88. So you can decide to round the values if you want to build a rounding algorithm in JavaScript, it's actually pretty easy. Like you can do that as an assignment or something, you know. But this basically that's the data for you. So what I was really going to teach you guys today was how to, I guess, harvest your data, right? Because you can't really do much with this, like unless you want to write a scripting algorithm and script this, and I mean that makes no sense at all. So the guys at the Things Network were really great to allow you to do some integrations. So we have MQTT, we have webhooks, we have storage integration, AWS IoT, Azure or Azure. I say Azure, people say Azure. So wherever, depending on where you're from, it could be Azure or it could be Azure. I say Azure. So yeah, I'm not sorry. But yeah, so we are going to try a bunch of integrations. Today we are going to try with MQTT. And so let's go here. And if you want to do this, you can like straight away just generate this, you know, and it will like create this for you. Feda Laura comes at TTN. I guess this is all like, you know, an example that I'm doing. So that's why you see my keys and all, but like ideally you shouldn't be showing your security keys to people, right? Like this app is just going to be dormant, so don't mind me at all. But like don't be, you know, giving your security keys to people. So this is the public address, this is the public TLS address. Then you have a username, and then you can generate a password, right? Now let's all install MQTT support on our computer. Okay, so to do that, you can just say download MQTT Windows. I mean, it will take you to the okay, so download Eclipse Mosquito. So how does MQTT work, right? So it was started by two guys when they were building this pipeline monitoring app in the US, and at that time satellite communication was the thing, but it was extremely expensive, so they had to come up with a way where let me open this MQTT, right? So generally, let's say we have let's do this quickly. Insert icons. Oh, this is taking so long. So let's say we were trying to do this. So let me add a few icons like person. Okay, this looks professional. So person, what else? Web. Let's say world. Since it's a World Wide Web. Okay, I like this. I want one with Africa showing. By the way, this map you see, okay, this is a little history, but like the map you see here, Africa is actually really bigger than they represent it on the map. It looks, you know, yeah, it's like actually extremely big. If you look up, so the proper map of the world is this. Let me show you. Autograph map. Yep. Because you see the earth like is spherical in shape, so you can't really just spread it out and have it, right? And if you see the autograph map, it will mess with your brain. So this is you see how big Africa is. You see this, like, you know, I just wanted to, like, you know, so you're not just learning about tech, you're learning a bunch more. And you can see this is what South America really looks like. See how big it is, you know. But these guys, they will shrink you so that they can say you are overpopulated. Well, I hope this video stays in here. Anyways, you know, so now that we're done with the philosophy, you know, back to technology. And so have a person, let me just bring up phone. Let's see, okay. Let's say computer. Okay. let me just find a bunch of computers. Then okay, these are okay. Then let me look for a B, and everything will make sense soon, so please forgive me. All right, so let's insert all these plenty things. Boom, pictures inserted. All right, so I'm going to just go ahead and drag these things around. Okay, and we are going to do some examples. So let's assume that this is some server sitting somewhere, and this is Francis over here, right? And Francis is such a professional. He wakes up and checks the news, so he uses Google News, and every day in the morning, you know, he would try to request data from Google News. So to do that, he would send a request to Google, right? And when the request reaches Google, guess what Google will send back? A response. Okay, that's what Google sends back, a response. And I mean, not just Google, like, I hope you get the point I'm trying to make. I'm not just talking about Google, but anytime you request anything from a web page and you are doing something like HTTP or HTTPS, right? So any type of request response, so request response protocols, right? Any type of request response protocols. Oh, sorry. When you send the request, right, the server receives your request and then it sends back a response. So what's really happening is that your computer will let me put this here. So your computer will send a request, right, and then a response will arrive, and your computer will have to download all the responses again, right? So all the images you see when you open a website and all that, your computer literally downloads those images and then it renders it for you. Okay, that's how. So you make a get request, right? When you make a get request, that's what happens. When you make a post request, the computer is waiting to download the information back from the website, right? So to request anything, Francis has to like make these things. But then again, Francis is building a web service, right? And he doesn't want to. So yeah, let's say this is some server here that is linked to it. And then one day Francis realizes, oh no, I can't be doing request response all the time. So guess what I want to do? I want to play around with sensor data and build some sensors. Now, we already established earlier today that doing acknowledgements on low power devices is really a no-brainer, right? But you know, never mind. So yeah, we have this here, and let's say Francis has built some cloud service that is doing whatever, you know, it's part of the internet. That's why I just put this arrow here, don't mind me. But then he has a sensor in the field. Oh, I didn't add a sensor. Okay, so let's say Francis has a company and they got a contract from the Environmental Protection Agency to monitor how much sunshine or heat, you know, let's say is generated here in his community, right? For maybe cattle farmers or something, right? So he has a sensor here in the farm, which is this really nice looking field over here. Let me change the color to I don't like this color. Green to represent growth, right? And we have this B here. Okay, so now the way MQTT works is different. So let's assume you have some sensors in this field here, right? Now instead of sending data, you know, to some web address and then getting the data back and all that, right? Hold on, let me just put this arrow here so that it shows. So like when you query something from the web, it goes to the resource and gets it for you. I just wanted to get this clear, right? And so we have this thing here, and we have this here, right? So the way MQTT works though, it's different, right? We have stuff that we call rooms, okay? Now this is what we call a broker, and like any person, a broker is really more like a middleman, right? So you are looking for a house, an agent, a broker. You like to gossip. Your gossip buddy comes to you, yo, Charlie, new filler in town, right? Also a broker of information. So we are always surrounded by brokers. You need something to be cheap. The seller isn't selling it for cheap, so you find your friend to talk to the seller. So every day, brokers, without brokers, we will really be broke, right? And so we have this here, and we have our broker here. Now the way MQTT works though, it uses and you see this a lot if you want to go into cloud computing and build remote sensing technologies, right? You see publish, subscribe protocol, okay? People shorten it and call it pub sub. The first time someone said that, I thought he was actually talking about a pub, like let's substitute the pub we are at because we are in a pub, and I was so embarrassed, but that's a story for another day. So we have this publish, subscribe, or pub sub. And what happens is that any entity that connects to this, you can either connect as a publisher or as a subscriber, right? So let's say we have a sensor in the field. That's going to be all for now. Let's keep things simple. Every 30 seconds, the sensor will turn on and then send data to the broker. So what do you think it's doing? Is it publishing or subscribing? It's publishing, right? Because literally it's like input output, right? So we are publishing, boom, and so the data goes here, right? We'll come back and look at the format of the data we are sending soon enough. So we publish data to the broker. Now Francis has this offsite server room or something for the company that he's working with. Let's say the UN is doing some statistics and they want to get a realistic figure of maybe cattle migration patterns, whatever, right? So we have this here, and we have publish, subscribe, and so we have this computer here that's, let's say, doing some work, right? So for this one, what do you think it's doing? Is it publishing or subscribing? It's subscribing because it needs to receive information to this, okay? So then we have this too. Let me group this, right? And so we have this too, this broker, and another device somewhere, like let's say this is some master room somewhere, or Ghana Aviations because they want the data because something, or anything, right? So what do you think? Is it going to publish or subscribe? It's also going to be subscribing, right? For now, we are keeping things simple. So now you realize that this mosquito, whatever, even though it's a B, because it's MQTT, you can say mosquito, right? Because if you spell mosquito, you have MQT, but it's only a single T in mosquito. So if you fail your spelling bee, don't blame anybody. So we have our broker here, right? This mosquito here, and because of this broker, now it allows us to be able to send data from anywhere to anywhere in the shortest possible time frame, right? Because what happens is this. So it's funny, we say, oh, publish, subscribe, but really what's happening, it's still kind of the request response, really. It's just that it's slightly different. So there are different types of requests, right? So you have a get, post, update, delete. Sometimes if you're using Node.js, you see these options. It's like usually when you don't have a proper headers, or if you have more formed headers. But I'm no expert on that. You have patch. There's so much. Like, look, you can look it up. But basically, the format of any web request, right? It's just, you hear this a lot. CRUD, which is create, read, update, and then delete, right? If you come across it. So create, so depending on the data you're sending, you can be creating or reading or updating or deleting. That's the only, those are the four main, but yeah, don't worry. You will see those things again. You hear of things like REST APIs. I mean, one day you do that. I mean, we'll do a bunch of stuff when we work with webhooks and stuff, depending on how much time we have. Like, not today, but we'll be doing a lot of things because I want to make sure that when you guys go and then you join other stuff, you can be fully equipped, so, like you can flex on people. But aside that, it also helps your career generally because what I'm teaching you, very few people today, especially young people who actually pay attention to these details because there's so many frameworks you could use to get stuff done, but then when something breaks, that's what really separates you from people who use external tools because you understand the inner workings and you can go in there and fix things as opposed to somebody who cannot, so anyways, because we have this mosquito here, it's literally able to take information from here to here. Now what happens is that it still makes a TCP IP connection, right? Now when the information gets to the broker, as soon as it gets here, right, if you were building your own MQTT server, as soon as information reaches here, it just cuts, right? As soon as it reaches here, no response is sent. It just terminates so that it saves you resources by not waiting for acknowledgements. Remember we established acknowledgements are problematic, right? Now this guy, however, when he sends a request here, the request gets permanently open, right? The way the subscription happens is that he actually sends a request from here to here, right? But what really happens is that the request gets permanently open. So let me just make it dashed line, right? So the information goes here and it's saying, oh, I'm subscribing, right? So when it subscribes, well, you've subscribed, right? So this pipeline is going to stay open just so that, you subscribe once and then the pipeline for information stays open for as long as your device is able to connect, right? And then the same thing here. So let me just copy this and I will take this here and here, right? And so we're going to do this. So we have so let's say these are the subscription channels, right? These dotted lines are the subscription channels. So we've subscribed, right? Now the connection is permanently open, right? And every connection has a keep alive time so that if it's if the connection is open beyond a certain point, the connection gets terminated. So the question is, why doesn't this get terminated? The trick is that usually you would send non-data. I say non-data, but you could be sending something like dots or space or a new line, right? Literally, right? So depending on the architecture you're using, but I don't like Windows architecture, so I usually prefer this. But yeah, you could be sending stuff. You could be sending columns. Yes, I think what I used to do, columns, right? And then as soon as data arrives, in the background something like this is happening, but in the foreground, or you can just say the connection should stay open forever, right? You can set a header like that. So what happens is that as soon as data arrives, instead of this one polling the broker for data, because this pipeline is open, the broker will send information back to it, right? So that's what happens, right? So let's say if you have a friend who likes to gossip a lot, you don't even have to go ask him for information. As soon as he sees you, or as soon as he receives information, oh, I need to find Louisa, or I need to find Barnabas, I need to find Kobe, right? He goes around and looks for all the subscribers on their channel and just sends it to them. Similar to how, this is not the same way your phone, this thing works. So I'm just giving you an example. Like when you, let's say, receive a notification on social media, you just get the notification. You don't like actually have to refresh the app to see it, right? It's similar. It's like publish, subscribe, but it's not MQTT. Okay, so publish, subscribe, like how notifications work. Really, it's more like a publish, subscribe thing. Okay, so you subscribe to a newsletter. When there's news, you receive the letter because you subscribe to it. Okay, so I'm not going to go too deep into like how it happens in the background and all that, right? But this is what happens because of the broker. Now, so let's assume that you have the same server or the same broker, and you have sensors in a field in, let's say, Achimota or something, or like you have this project, you have another project you are doing. Let's say you're tracking vehicles. You own, let's say you own a sanitation company, or you partnered with a sanitation company, and you've built them some trackers for vehicles, right? So you have this really interesting, instead of let me look for track so that it looks badass. A track. Let me use this. This is more. Yeah. So you have some tracks, and let's say you have a fleet of vehicles, and you've built in some tracking system, right? And so every now and then, these vehicles will be sending their data to the broker, you know, so that you can track where they are at any point in time, right? So this is more or less, right? So you're subscribing. Now you realize that this is still over here, and the data could be confused, right? So you might have to build some way to check, like to make sure that, oh, the data is coming from a van or it's coming from a sensor in the field. Well, MQTT makes it easy for you because you have what we call rooms, okay? And literally it's like rooms, okay? Let's say you go to a restaurant and you need to use a washroom, and you go there, and because you're a guy, it says gents, right? You just have to respect that and use the gents washroom, and not, you know, right now gender is a bit confusing, but like you get what I mean, you know. So so we have our rooms. So let's say a room, like it could be cattle grazing, whatever. It could be cattle grazing, cattle errors, I mean, whatever you want, right? So we have some rooms here. And so let's say if you want, let's say this one has subscribed to some general room, some room somewhere called cattle, right? Then it's only data that gets published to that room, because ideally if you are in a room, then you can see what happens in the room, right? Because I wouldn't be able to know what's happening in like my room right now because I'm here. Okay, so the fact that you're subscribed to a room, when data arrives in that room, it comes to you. Okay, so that's the thing. So we'll do some examples. Everyone will send things to their own rooms, right? But I think I should have asked you guys to download Mosquito while we were waiting. But yeah, so this is the Windows version. You can install Mosquito. If you're using Linux, I mean, it's much easier. You know, you'll see the like there's so many, like Ubuntu. You can just do sudo apt repository this, and then you install it. You know, I think I should have done that. Let me open my Ubuntu CLI. Should I or should I not? Anyways, let's keep this simple. I don't think it comes with a GUI, or I might be mistaken. Maybe that's, I don't know. I haven't used it in a while. Let me do. Nope. Anyways, it's installing, so it'll be dancing. Alright, can you grab me something when you're coming? Yeah, the food or something. Okay, you know what, guys? It is 7:20 right now. I want to go to the cafeteria too. So let's end the call right now and meet at 8, if that's fine, so that we complete the other part of it. But I'd like to know what you think before we all right, so we're back, and yeah, so that's the broker link. So when you just add those two and then click connect. Right now, when you click connect, click new subscription and topic. Let's do this. Let's say Francis / hashtag, right? So I'm going to call this Francis channel. You can do as many subscriptions as you want, but if you do a subscription, you can add it to general. So let's see, let's do this to Francis. And if I send this, right, you see it shows in on my screen. Okay, so the reason why that happens is that for this topic, when I did Francis and then I put a slash and the pound sign, that means that like the hashtag, that means it's more like anything in any, like, so Francis is like a main room, but any sub room in Francis is going to listen to it, as opposed. That's why when I did Francis hi, it's still. So if I did Francis, let's say random, right, and I still sent hello, you see the topic is Francis random, but it still goes to hello, right? So let me delete this, new subscription, and let me call this, oh, if you have like the keys, just load it into the app, and then you can also send data. Just let me know what stuff you create. So let's say Francis messages, right? And now if I send the data to Francis random, when I send it, you don't see it here, right? But so if you all connect, then you can literally send. So I'm going to show you my subscriptions. This is going to be my subscription. I'm just going to subscribe to the main topic, right? Like everything that comes in. Okay, I cannot use that because of. All right, so let's do AccraWAN, and I'm going to listen on all channels. So the way you send data is you come to this side, right, the topic, and then you type any random topic, but make sure it begins with AccraWAN. So AccraWAN, and then put a slash, right, because everyone is sharing this same, like it's a test server, so everyone, a test broker, so everyone is sharing it. So you might want to create your own room, and let's say LOL, something, I don't know, just anything. And so Francis, you can also try and connect to, like, have you opened MQTT? It's installed. Okay, so let that finish. Louisa, how far with MQTT? Hold on guys, I'm helping Louisa out. I'll be right there. Yeah, so Louisa's message came through. She sent hello to AccraWAN. So you can edit this message thing here. You can call it temperature, right? And the temperature is 90.32, for example. If I send this, right? So Louisa, I can add a subscription to AccraWAN/LOL. Okay, like, and to do that, you go here, new subscription, and then yeah, just do AccraWAN/LOL. So now if I send this message again, the wizard should have received it. Did you receive it on your end? Yeah. Right. So that's how it works. So if any of you are there, you can connect to this. So basically we see this in action, right? And Francis, maybe when you're done installing, we can do this again. So I'm going to disconnect for now, and we are going to create an instance on the things network. Okay, so this is where we are going to end. Also, by the way, Terry is going to fill out our evaluations tomorrow, so we have to build a presentation to show him what we were able to do as opposed to what we couldn't, right? So let's see. All right, so these are the MQTT keys. We are going to try this. So let me try this. Okay, so we are going to try this right now. So let's call this TTN further low up, right? And our broker is going to be this one. So you collect eu1.cloud.thethings.network. I'm going to paste that there. Okay, so this is for testing and evaluation. Please don't be like, I mean, this video will go out, so I guess everyone would like be able to connect, but maybe I'll close this eventually. Yep, so I'm going to do this. And for username, what's the username? Okay, close this. So for username, I'm going to paste this here, and then password, I'm going to paste this here. So let me just put that in Discord as well. So name TTN, post. I mean, we know it's already MQTT, so don't worry about that, right? And then the port, I'm sending a message, so don't worry. I'm typing the message. So the port is 1883. Username is this. And then the password. Yep. So I'm sending this now, and I am going to connect to this. And it's connected. Okay. All right. And Alright, so I don't know which room it's listening on yet, but I think for this I can subscribe to all rooms. So let's see. Let's see. Wow, can't believe 30 seconds can take so long. Alright, let's see if this data comes across. Alright, I didn't see the data, so I'm trying to figure out how to get this thing to work. Okay. Tenant ID. Okay, so because I subscribe to a channel, I see this here, but I don't see the data sent. Let me see if it contains information on where the data was published to. I hope it does. That's the identifiers, type, okay. Alright, let's just check this. Okay. Okay. Here's the topic. Oh, okay. So I cannot subscribe to. Wait. But I subscribed to this and it didn't. I don't see any events when. Oh, okay. Let's see what happens now. Okay, and okay. data hasn't come in for a while. Let me see. If it doesn't come through, maybe I did something wrong. I will check it out. Okay, nothing came through, so I probably didn't do it well. I am going to go ahead and try it from here. Okay. Okay, so since we have this, let me just figure this out a little. Okay, so what is this? Yeah, I thought this thing would work, but apparently it did not. So I'm going to go back to the brick and mortar way. Alright, so let's subscribe to alright, and where's this code? So we want to use okay, mosquito sub alright, P 1883 U oh my god, not again. Yeah, I have to go and run. There's a few things that you don't have to do. I'll show you after the call so that you can run mosquito sub on like from the command line. But for now, if you do it, it's not going to respond because yeah, unless you open like a terminal in this. Okay, so let's do this again. Alright, so let's do mosquito sub he1.cloud.there. things.network P1883, then dash U feather board lower comes at TTN, and it should ask you for okay, and then the topic, put the hashtag there, and it should ask you for password. Okay, I think I have to put the password in line as well. So you might not want to do this in a real app because you wouldn't want to put your password on the internet, but I mean, for now, you know, this is all evaluation. So oh, this feature is not supported. Really? Oh, I think I made a blunder. Yeah, I made a mistake here. The port. So capital P is different from small p. And then let's do -D. Alright, so it has subscribed. And so let's see what it says on TTN now. Alright, so over here it says subscribe application, and I just want to confirm if we can see some data, you know. Alright, so a transmission happened, but yeah, we didn't see anything. Alright, I'm going to look into this because this shouldn't be happening. Oh, okay. Okay. So this is the application ID at tenant ID. Okay. Oh, so this is how you subscribe to upstream traffic. So but yeah, when I select everything, it should arrive. It should at least show me the place where data comes to. Well, I'm not seeing that, so I'm a bit confused right now. Let me try the thing with the tenant ID, else we'll have to try again. We'll have to try another thing. Okay. V3. Okay. V3. Oh, okay. I think on this time I have to use right on Windows. Okay, V3. Yeah, I don't know how to see the data yet, so yeah, I think I'll log off right now, just so that we figure this out, and then we do it so we don't waste extra time. But I'm going to try one more thing and then we'll go. Alright, so application ID, what's there? Then we have a tenant ID. Okay. Another tenant ID. I think it was tenant ID, and then let's try this. What's the device ID? Okay, let's use this device ID for now. Also maybe I'll reach out to Nick and see if so let's try one more, and then if it doesn't work, we will call it quits here. Alright, I guess we can call it quits. Yeah, I think we should end it here, and then I will figure out what the problem is, and we'll okay, dash pretty. Oh, okay, I need to add v, and then yeah, I need to add v dash small v. Alright, okay. Yeah, I don't know if that's going to, if it's going to send data to it. I think it should, but it isn't, and we are not seeing it, so yeah, so you know what, let's end for now, and then when we figure that out, you know, we will yeah, so I'll figure that out, and then we'll do another session. Also, I'll just keep going around in circles, so let's do that. I'll figure out why it wasn't working.